Okay, so I've been asked about this question here. I just want to make a quick video of demonstrating how I would go about solving this. There's one thing that I'm going to talk about a little bit as we look at this, and that is the ambiguity in this question. Now, it says how many six-digit even numbers are there that are less than 300,000 with no repetition of digits? So this kind of depends on the way you want to look at six-digit even numbers. So would we consider a number that starts with 0 to be a six-digit even number? So if it was, for example, 0, 1, 5, 7, 3, 2, would we count that? And that kind of just depends on sort of your way of looking at it. Typically, data questions are more straightforward than this, but I've seen some argument between various students and teachers over whether or not they'd include that. Um, but let's just assume that we are going to say it can start with 0 and still be a six-digit even number. Okay, so it has to be less than 300,000. So that means it can start with a 2, a 1, or a 0. So let's take a look at this first row here. So if it starts with a 2, that means we've spoken for that first number, it's a 1. Now, it has to be even, and it starts with a 2, so how many even numbers are there in terms of digits from 0 to 9? There's 0, 2, 4, 6, and 8. So if you count those on your finger as I say them, let's go over that again. 0, 2, 4, 6, 8. That's 5 numbers. So, but we've already used up a 2, so we actually only have 4 options here. Now remember, there's 10 digits from 0 to 9. So, and we've spoken for 2 digits. So that means we're left with 8, 7, 6, and 5. Okay, now in the next case here, we're saying that it starts with a 1. So if it starts with a 1, we've spoken for 1. And then we have this last digit here. This is the next one I'm going to go to. Remember, it has to end in an even number to be an even number. So 1 is not an even number, so we have all 5 even numbers we can use. So at this point here, we've used up 2 of the 10 of this column. Sorry, of this row. So now what we can do is we can just fill in the rest. So we have 8 times 7 times 6 times 5. Now we have our last row. And this is the row that I was saying, this is where the ambiguity comes in. On an assignment, I'd probably accept if a student answered a question like this and they didn't include this last row, or if they did include it, because I think that this is kind of an ambiguous case in terms of the wording. I would probably be inclined to actually not include this, but uh, again, that just kind of depends on your way of looking at it. Okay, so if it starts with a 0, then the first number spoken for, it's 1. And 0 is an even number, so we've used up 1 of the 5 even numbers, so we only have 4 left. And now at this point here, we've used up 2 of the 10 digits. So that leaves us with 8 times 7 times 6 times 5. Okay, so what we can do next is we can just multiply all of them through. So that gets us 6, 7, 20, 8,400, and 6, 7, 20. So remember, it can be case 1, or case 2, or case 3. So when we hear the word or, we're thinking add, and these are all mutually exclusive events. They can't happen at the same time, so there's no subtraction to worry about. There's no overlap to worry about. So we add those up. 6, 7, 20 plus 8,400 plus 6, 7, 20 equals 21,840. Oops. And that's all there is to it. So again, this is probably one of the harder questions that you'll encounter in this entire course, in my opinion. So if you actually were able to follow this along, you're doing pretty good. If you're not quite there, don't beat yourself up. This is probably one of the more difficult questions to wrap your head around. But maybe if you step back for a day or two and then revisit it, it might actually start to click. If you have any questions about it, just ask them in this thread, and I'll do what I can to try to answer them. Just try to be specific about what your questions are, because it's very difficult for me to just answer it if you say, well, I don't get it. You've got to kind of let me know where I'm losing you, and then I can maybe try to expand on that. All right, thanks.